then we're going to see in the logs if the traffic is actually going there or not. Alright, without any further ado, let's begin. So first of all, you need to create a community object to build up a VPN. You go for new, click more, go for VPN community. You can choose star community if you want to have a specific routing between your central VPN and satellite ones, or a meshed one. They will be able to build up a tunnel between each other. So we're gonna call it, let's do it VPN for FTP. We have a purpose, right? So we don't do anything without a purpose. It would be pointless. I've already added a second device here to my smart console, and we established a SIG connection. So we're going to add it from here. You just click plus sign any gateway you want to include inside your VPN community. You do it here, they will be able to build up VPN with each other. Then you go for encrypted traffic. So that setting here, what it means, if I check that, accept all encrypted traffic, you will not have a necessity to create a firewall policy to accept the traffic. If you check that, it will create implied automatic rules to accept all your encrypted traffic. If we uncheck that, we will have to manually define our rule base in a firewall. If you check that, it's pretty easy. You don't have to do anything. So you can leave it like that if you want, like check that. But since we are, you're getting my knowledge, I'm gonna uncheck that and show you a more complicated way, but the more granular control way. Then you go for encryption. So over here, what we can pay attention to. So we have phase number 1 and we have phase number 2. These settings have to match, but since these firewalls, these two gateways, are being managed by the same management server, and this is the only tab we have for configuration, that kind of stuff, they will match. That's 100% because this is the only tab we have. If you have a different management server that manages a different device, that settings that you set up over here, they have to match on the other side. They have to be the same, right? Even like aggressive mode, perfect forward secrecy, all that settings, they have to be the same. This is really important, and that concept seems really easy, but over and over, I fix cases like that all the time. Maybe like even couple cases a day, VPN cases, just because people cannot, they don't understand that have to match. Once you watch my lecture to see how the tunnel is being built, so you're gonna understand, maybe a bit more about that. Then you go for tunnel management. So we're gonna leave permanent tunnels for now. Don't check that. So what it is, a certain amount, whenever a certain amount of seconds passes, or a tunnel reach a certain amount of kilobyte, it will reset it. If you don't really want that, you have to enable set permanent tunnel. It's gonna send out keep alive packet, and the tunnel will not be reset and reestablished. As for VPN tunnel sharing, the most recommended way to do that is to use VPN tunnel per subnet pair. It applies to a second phase when we set up subnetting. Whenever a subnet tries to build up a tunnel, it is going to build it based upon its subnet. So we're going to build a tunnel, let's say a host from address 172.16.10.2 is trying to build a tunnel to something else. When the tunnel is opened for the second phase, it is going to open for the whole subnet. The whole subnet will go through the tunnel. And with that being said, the keys, encryption keys that encrypt the traffic and decrypt the traffic will be open for the whole subnet. If you used for each pair of hosts, a different set of keys for encryption and decryption will be used for each tunnel that is for each host that is trying to open up a connection. That kind of increases an overhead. That thing, it will open up a tunnel for your whole gateway. Everything that is behind your gateway, it will build up a tunnel and it will be used to encrypt and decrypt the traffic. I'm going to leave that for now, and honestly, I've never seen anyone use anything else but that in years. Excluded services, if you want to exclude anything from your like services, let's say you don't really want I don't know, whatever this is, you don't really want like DHCP or whatever to go through your tunnel, you can exclude that and it will be denied on firewall policy. It is really useful, especially if you want to accept all the traffic, you don't really want to bother with the firewall rules, you just check that. Okay, and then you go for exclude services and then you exclude specific services. But we're not going to do that, we're going to do it more complicated way, so we're going to leave that blank for now. As for shared secret, it is an alternative to certificate to build up your pre-shared keys for your phase number 1. It is less secure, but it can be used to, especially if you don't want to exchange your cert, you can use that with third-party vendors or a second checkpoint firewall that is being managed by a different server. You just click here and then you have your peer name that is interoperable device. It's not managed by that firewall, and then you put up a secret here. Wire mode, it is really useful, especially if you trust these networks and you don't really want them to be inspected by checkpoint stateful inspection. You don't really want to flood your firewall stateful inspection table with that stuff, especially if you trust your networks 100%. As I've told you, tunnels are not permanent, they have a limit. So checkpoint usually does that thing by seconds. Some vendors do it by kilobytes. When a tunnel reaches a certain amount of time, it resets the tunnel. Checkpoint does it by seconds, and for the first phase, the default value is that number in minutes, and for the second phase, the default value is that value in seconds. As for NATing, you can enable NAT inside your VPN community, or you can disable NAT inside your VPN community. So when you check that, honestly, it seems like it's not a big deal, but it is a big deal to check it or uncheck that value over here. So I'm gonna, honestly, that thing goes to CCSM series. If you type in FWCTL chain, how the traffic is flowing between different daemons inside the checkpoint device, checkpoint has to know whether to NAT the traffic and then put it to TCP IP stack and then put it in VPN stack to decrypt, encrypt, and stuff like that. So if you're enabling VPN inside your VPN community, so what is going to happen? Traffic will be encrypted, then it will be NATed. But you have to understand that that NATed traffic you are translating might be a bit different from what the other side is expecting. Remember, I told you configuration have to match, even subnets. If it's not matched, the traffic will be dropped. You will not be able to establish a tunnel because the other side is expecting a value that you define. It's expecting the proper subnet. If you're not that, it will be different. But in certain scenarios, I've seen customers like that, they need that. Especially, usually the way it works, you NAT a traffic on your router behind your firewall, and you put that subnet inside your encryption domain. If you do it here, it will be a bit more complicated, but it is possible. We're gonna check that because I want to disable that thing. I don't want to see it here. Then you click OK. Then you have to go to your device. You go for gateways and servers, you click your gateway, and we have to define encryption domain. We have to define a subnet that will be put through the tunnel and go to another encryption domain. You do it from here. You click network management and go for VPN domain, that configuration here. You then go for manually defined, and you basically define a subnet. So I'm going to define 172.16.10.0. So I'm going to view that. That is the subnet I'm going to be putting behind my encryption domain from my site, from attacker/smart console side. And as for the second site, I've added another gateway as I've told you, and we're going to do the same thing here. You can see I have IPsec VPN enabled, then go for network management, VPN domain, and I have 10.10.10.20.0 network. View details. There you go. You can define way more subnets if you want to. If you want to do that, you have to create new group, simple group, and put all these networks inside that group. And then you're gonna click OK. All right. So you're gonna click yes. Configuration that I want you to pay attention to when you're doing the that kind of stuff. You go for the tab that is called IPsec VPN. So over here, not too much difference. The only thing you can do, you can choose a certificate, upload your own one, or use the default one that Checkpoint Management Server generated, and it's been its own security authority. The thing I want you to understand is what Checkpoint is going to be using for its peer IP, the external IP address that devices use to establish a face number 1. You can use the main address. If it says the main address, it's going to be using that address. This is the main address. You can choose your own one, choose from the topology table that you have, or statically not an IP. You can play around with that. I usually use the main one. You know, it just works for me. The rest is a bit more complicated. I'm going to leave it for now. Then you just click OK. Remember, I've told you that we're going to make it a bit more complex. So we didn't check accept all the traffic. We're going to do it manually from here. So the way you do that, you create a rule. Just let's do a couple rules. We're going to accept the traffic. The last rule will be our cleanup rule, regular one. Let's just log it. Let's log everything. And so as for the source, you want to choose a subnet that we define under our encryption domain. It's that one. And the subnet that I have is called like that. We're going to drag and drop it. Yeah, honestly, with Checkpoint environment, it's not too complicated. Okay, we're actually going to delete that rule. And for the purposes of FTP, actually there is a tab here that is missing. If the tab VPN is missing, you have to right click on this gray tab here and check it. So for VPN, choose your community, specific VPN community, and we're going to go for a VPN for FTP. And now we're going to make a granular control. I want to accept FTP. So let's go for FTP. I want to check everything that's related to FTP. And actually another thing that you want to use for FTP is TCP higher ports, because FTP is using randomly generated port to open up a connection. At least I have to find that higher ports. As far as I remember, FTP is using something far above 40,000, but this is used like over 1023. We're going to be using that. It is going to work. At least it's more granular than accepting everything. And we're going to install policy on everything. So we're going to include our 2 gateways that we have. So all right, now we have to establish install the policy. It will be really fast for you, and let's see how our VPN works. The policy has been installed. As I've told you, we have our FiveZilla FTP client on our attacker smart console side, and somewhere else, you know, on that topology, we have our FTP server. Okay, let's try to connect using that password, attacker password VPN123, quick connect. Okay, let's do that. A new tab. Okay, the connection is successful, and let's go for the logs. Then you go for logs and monitor, filter by blade VPN, and filter by service FTP. So this is the rule we have, the one I've set up. So here, as you can see, we have encrypt connection for our gateway, and we have protocol FTP. Everything is working. This is how you set up VPN for two devices managed by the same cluster Excel. In that lesson, we're going to discuss what is a cluster, what checkpoint defines a cluster, different types of cluster requirements, what you need to have to build a cluster, and we're going to touch a bit of topic called synchronization, basically the mechanism that allows the traffic to be synchronized between appliances. Alright, so we have Firewall 1 and Firewall 2. Let's say it is a cluster, and right now the traffic is being passed through Firewall 1, and the second firewall, Firewall 2, is just watching what is happening to Firewall 1 to be able to pick it up. To properly define a cluster, we need to have three components. The first one is called redundancy, meaning that your solution is redundant. If Firewall 1 fails, Firewall 2 will pick it up. Alright, it fails, the second device picks it up. Easy. Alright, the second thing you need to have, your solution has to be transparent. If you have to manually change routes, whether on the client machine or on your router to be able to pass the traffic, yes, your solution might be redundant, but it's not transparent. If it fails, if the admin has to do something, you lose time. Because basically, admit it, like maybe it might take you 5 minutes. You call an administrator, hey dude, like you have to change a route. It might take longer. Who knows? The solution has to be transparent. Let's say you have a virtual IP address, and we're going to discuss it a bit later in more detail how it works. You have a virtual IP, and so you don't need to change routes. The failover is automatic, and the second firewall takes over without any need to change routes on your router or on the client machine. This is how Checkpoint defines a cluster. Your solution has to be transparent to the client, to the router, to everybody. It has to be redundant and transparent. In the active scenario, there is a thing that you need to have to properly define a cluster. It is fault tolerancy. So basically what it means, we can balance the traffic between your firewalls, between your Firewall 1, Firewall 2. You can actually have more than two firewalls in that scenario, in load balancing scenario. But the thing is, to define a cluster properly, if one device goes down, the second device needs to be able to pick it up 100% of the traffic and not like crash because of that. If the second device is crashing, let's say they balance in the traffic, but if one device crashes, that's not fault tolerant. That's just not the way we define a cluster. Okay, so we have redundancy, transparency, and fault tolerancy. These are the principles how we define a cluster, and if something is not like that, it's not a cluster. Okay, I think I mentioned that more than enough. Let's go on. Two ways cluster can be deployed. The first one is called high availability. Two technologies you can implement here in terms of high availability. The first one is VRP. It's called Virtual Router Redundancy Protocol. It's a common clustering protocol that other vendors use, and checkpoints can work in that mode as well. The second mode is called New HA mode. It was designed by Checkpoint, and I would say it's mostly used in a customer production environment. The way it works, we have two devices. One device is passing 100% of the traffic. The second device is being on standby, and if something happens to the first device, the second device takes over all of the traffic. It's being transparent, redundant, blah, blah, blah. you get the idea. All right, load sharing, load balancing mode. Basically, we split the traffic between our devices. We can have more than two appliances or virtual machines as firewall instances. We can have 3 or 5 and split the traffic between them. So when we have, let's say, 100% of the traffic coming to our external interface, to our router, in unicast mode, the traffic is being split as 30% to 70%. In multicast mode, it splits to as 50% of the traffic. Same works for unicast, multicast, or HA. If one device fails, the second has to take over. in load sharing, load balancing environment, it has to be fault tolerant. So it has to make sure the second device will take over and its CPU will not be 100% and it will not be dropping any packets with any kind of error messages, but it has to be fault tolerant. We're going to go deeper into how unicast and multicast works, what's the difference between them. I'm going to go and discuss high availability and how it works in more detail here. We have two appliances. The first one is 10-10-10-10. The second one is 10-10-10-20. For the cluster to work in transparent mode, it needs to have virtual IP. In our particular instance, it's going to be 10.10.10.30. That address has to be routable, and you specify that during the cluster installation. And we're going to go through that procedure in the lab as well. So when we pass the traffic to our virtual IP has to route it to our active device, to our active firewall member. That is actually a name for the status active device. It's passing 100% of the load, and the standby device is passing 0% of the load. But the traffic is being synchronized using CCP sync protocol. So we connect a cable in our sync interface on one device to the sync interface on the second one, and the traffic is being synchronized every 0.1 seconds via the wire. If one device goes down, virtual IP, it can go down, different way. Maybe the process crash, something happens to the cable, a machine crashes, or maybe an admin uninstalled a security policy, whatever. If that happens, your virtual IP knows that the traffic that device changed the status from active to down, and reroutes the traffic for the second device, and it becomes active, and it's passing 100% of the load. And the first one, of course, is 0% of the load. So what happens to our device that became active during a failover if that guy comes back to life? We can specify that in our policy. It can actually stay active, if we specify maintain current active cluster member, or we can click here, switch to higher priority cluster member, and we define a priority in a cluster members. So if we keep maintain current active cluster member, it's going to be active, and that guy will be standby until another failover occurs. If we switch to higher priority cluster member, they will just switch to what it was before. That guy would be active, and that guy would be standby. Cluster XL load sharing. So the difference between the regular HA is basically you get enhanced throughput because both devices work in the active state. You don't have the active standby scenario anymore. You have active one. So both devices receive a packet, and they decide who will process the packet and who will not. So the device will drop it. It's pretty much the same. You still get transparent failover in case of any kind of failure. As I said before, this principle is called fault tolerancy, and Checkpoint sticks to that. So as I mentioned before, load sharing has two modes. The first one is called multicast, and the second one is called unicast. There's a difference between them, and first we're going to discuss how multicast works. So we have virtual IP that is being associated with all cluster members. Whenever a virtual IP receives a packet, it sends it out, the same packet, to both devices. It can send it out to other devices in a cluster membership. Cluster XL load sharing can support up to 5 devices. So all of these devices that are in our cluster membership, they receive that packet that our virtual IP has received. And they have, all these devices, they have to agree with each other who will process the packet. All right, so what happens next? If our device has fallen, our warrior has fallen, what happens is the second device pick it up, and all the traffic that was associated with that device will be associated with the second device. It will be active, that device will go down. All right, so I know it might seem a bit complicated, so let's just go over the traffic flow. It's gonna make more sense. Alright, so multicast mechanism associates virtual IP address with all cluster members. That's what I told you, right? All packets sent to the cluster IP reach all gateways. That's what I told you. Alright, look at that. We have a TCP connection flowing. It gets to our virtual IP. It's not going to one device, it's being split, right? So for two devices, the same connection. And then each member decides if it should process the packet. They agree with each other using the TCP sync interface. And if, let's say that guy, 10, agrees to process the packet, it assigns that thing that is called sticky decision function. And he knows that that connection will be handled by this guy. And that guy, at the same time, will still receive a packet, but it will not be able to process that. It will drop the packet. So that mechanism makes sure the packet is not being inspected twice. So this way we utilize our resources more properly. When it comes to load sharing, the difference is we use a unicast traffic, and the virtual IP address always associates the packet that was destined for to pass through our firewall with only one member of the cluster. We choose it manually, who will be our pivot. This is the term for the member in the cluster who decides who will process the packets. There is actually a reason why we have two modes, unicast and multicast. You might say, what's the big difference? I don't care how the traffic is being passed, whatever. But there is actually a big point. In most environments, I wouldn't say actually most, in some environments, some switches and routers are not able to handle multicast traffic. So that's why you have to use unicast. There are ways, to work around that. And all right, so in that scenario, the traffic is being split as, let's say you have two devices, as I have in that topology here. We have one pivot member, the guy who handles the sticky decision function. It assigns that tag to the packet, and other cluster members will know who will handle the connection. Because pivot member in a cluster is doing a big job deciding who will do the main work, it actually doing a lot of stuff. That's why it handles traffic as well. It might assign some of the traffic to be handled by pivot mode. Because of that, because of too many functions he's handling, he's taking around 30% of the load, of actual load that's coming to virtual IP. And other members taking, the rest, 70%. So it's taking less. Traffic flow. We have our TCP connection that's going to our virtual IP. Instead of just going for two devices, it's going to pivot because it's unicast. It's associating with only one IP, with our pivot one. Only pivot member performs sticky decision function, SDF. In multicast, two devices perform that function. Two of them do that. If the device goes down, the second member becomes a pivot and it performs SDF. All right, our device went down, somebody broke it. This TCP packet is going for 10.10.10.20. And now we change the status. That guy is active and this guy is down. This guy, have 70% of the load, but it will be handling 100% of the traffic. All right, cluster requirements. It's not too much of the information here, but that information that I have here, it is really important. All of your devices that you want to include in your cluster membership, they need to have same OS, same operating system. They need to have same hotfixes and same hardware. Okay, for example, if our operating system is Gaia R80.30 or 20, whatever, it has to match, right? It has to be Gaia R80.30. Let's say we have Jumbo Take as for hotfix. Let's say it's I don't know, just from the top of my head. Okay, it's gonna be 86. Jumbo Take 86. It has to be the same. And same for the appliance. If the appliance is 5800, it has to be 5800. They have to match. Easy. I'm not gonna focus on that. Over the past 20 minutes, I've talked how devices know where to send the traffic, about their states, whether the one is active, whether the one is standby. If one goes down, you know, the second device knows for sure it's being down and handles the traffic. Okay, now it is the time to know the truth. What is happening? Synchronization. We have a packet that is called CCP. It is a cluster control protocol designed by Check Point. We have two types of synchronization. The first type of synchronization is called full sync. The second one is called delta sync. Full synchronization happens when we have to synchronize the whole connection table from scratch. If one device is active, the second device is standby, and the second device went down, it comes back to life, and it has to synchronize everything from the active cluster member. So in that case, we use full sync, and in that particular instance, it operates on encrypted TCP port, which is 256. All right, so the second type is called delta sync, and delta sync is using same cluster control protocol, and it works on that port 8116. It's being sent every 0.1 second to every interface to make sure all interfaces are online, working fine without any problem. If there are any issues, it's being reported over that port. So devices know whether a second device is alive because of that. Basically, when devices have been synchronized with the full sync after one device went back online, if they are working fine in production, let's say we have active standby configuration, and it's working just fine, to synchronize new connections, we're going to use delta sync. So CCP packet on port 8116, responsible for that as well. I'm going to demonstrate it for you. Look at that. We have TCP connection that's going to our active device. It's being added to our connections table. Remember when we spoke in our checkpoint introduction lessons how stateful inspection firewall works? So that's basically it. It's being added to our stateful inspection table in the kernel. We have that connection that's being on our firewall, and then the packet goes, somewhere that it was destined to. At the same time, okay, we have a second connection as well, just to show you a bit more complicated stuff. Not one connection, we have two. That connection is being sent out to standby device, but then it's actually way too slow of the traffic flow that I have. It happens over 0.1 second over the sync interface. It's being added, duplicated to connection table of the standby device. Same for the second connection. Regardless of how many of them we have, it's going to happen, over our sync interface, the CCP packet. Just to remind you, because it's really important, if you reboot device, or just joining the cluster and you have to synchronize your whole connection table from scratch with the active device, it is called full sync. Works on encrypted TCP port 256. If you're gonna troubleshoot that in the future, why it's not working, if the traffic is being blocked, whatever, you're gonna use that port 256. And delta connection only for added connections. Working on all interfaces. Yes, so what it's doing is synchronizing connection tables, health status of interfaces, and if states of our firewalls are changing from, let's say, active 1 to down, or whatever state it is, this is how it knows what is happening. Hey everyone, and in today's lesson we're gonna learn how to build up a cluster, whether it's high availability, regular way, or it's load balancing. We will do that today. Okay, so to begin with, you have to click new object. Let's do it from here, and then click cluster. Alright, cluster. So there are different ways how you can build up a cluster. You can build it up like from scratch, when you install a Gaia operating system. You can do it by wizard mode, it is said to be more, user-friendly way. Or you can do it using the classic mode. So what I want to do for you to learn that stuff, I will do that using a classic mode and show you all components you need to have in order to be able to build up a cluster. So once you know all of these components, you can use all other methods available for you, whatever seems easier for you. But let's go deep into classic mode. Just click here, you will see a regular tab, the tab that you usually see when you create a regular gateway, and just give it a name. I gave it a cluster 172.1610.104, just the regular IP address from my subnet. As for the IP, same IP address. I gave it a name. I usually do that, for one reason. It is more comfortable to find that object, especially if you have lots of them. So the IP address you can give it here is basically from any subnet you use. I usually use the one I use for management. I just gave it, a random 104 address from my subnet. You can use whatever you want, really. So then you navigate to cluster members, and so over here you're gonna have all of your members that gonna participate in a cluster membership. I've already had threat emulation device with that address. You already know that from topology 172.1610.1, and in order to build it up, you have to install a second device with the same configuration, same operating system, same hotfixes. It has to match. It has to be absolutely the same. It has to be the same license. It has, the same amount of RAM, the same amount of CPU cores, whatever. It has to match. If it doesn't match, you will not be able to build up a cluster. So keep it in mind. It is really important. Even though a lot of people say about that, people still build it up using different configuration, and then they having problems, and then they try to troubleshoot for, God. I'm not even gonna say it, but believe me, just keep it in mind. It is really important, okay? Once you add both of your devices here, then what do? You navigate to network management. Just click right here, network management, and over here you're gonna have a topology. So what is really important here? So okay, first, interfaces. For one device and for the second device, we have the same amount of interfaces. All other interfaces that you are not using, just disconnect them. Do not enable them, because basically if you have your interfaces enabled on one device and they are down, it might work if it's one device, if it's not a cluster. If you're not using an interface, let's say Ethernet 8, I had Ethernet 8 here, and I'm not using that, it's down. It's fine if you're not using that, if it's a regular device, regular gateway. But if it is a cluster, it is going to report to the second member in the cluster membership that one device is down. Since it's down, it's going to say, hey, I have a problem, and they're going to fail over. And the status of the device will go to down. You kind of see the idea here, right? So if you have 3 interfaces here, just keep them 3. All other of them are down. This is for the name, right? As for the topology, so over here you just define whether you have the external interface or a private one. For my configuration, that subnet is my external subnet. All of these are my internal ones. Pretty easy now. Alright, so over here I have 2 devices. You have to drag it just to see what kind of device I have. Yeah, it's not really convenient, but you will get used to that, especially if you have it like a big screen. Alright, so as for the external interfaces, for one device, I have that address. For the second device, I define an address from the same subnet. And the virtual IP address, it has to be from the same subnet. The virtual IP is the address that is being associated with both external addresses of your devices. So it is necessary to assign it for the cluster to work properly in order to basically route the traffic. If I just open that, you will see all regular information here, where the interface leads to, what security zone it is assigned to. It will show you what members belong to that virtual IP address. And the most important thing here is to look here, network type. So over here, I can define whether that interface belongs to a cluster, belongs to a sync interface, cluster and sync, or a private interface. So what I'm going to do, I'm going to define it as a cluster interface because this is my cluster virtual IP interface. So all right, next interface, let's go for Ethernet 2. I'm just going to double click it. So over here, you can see members IP, what IP belongs, what members belong to that virtual IP address I've opened up, and I've defined it's a cluster interface. It's basically that address here is my virtual IP and it's a cluster interface. It belongs to a cluster. It's virtual and it belongs to a cluster. And over here we see it leads to our private network. We're gonna close that for now. And as for Ethernet now, there's like a small difference here. So I've assigned a virtual IP from the same subnet. It's virtual, but apart from being only a cluster, it's gonna be plus sync. It's gonna synchronize the state of your connections. When we spoke about firewall, we spoke about the stateful table that is stored in kernel. So this is basically the interface we're going to be using for syncing that connection. Sometimes you can use a separate interface if your topology allows you to. Let's say you just click here, sync. It's only going to be using for sync. But you can, say I want to use it for cluster and sync. I want to use my virtual IP for that subnet. And that is exactly what I want to do in my topology. And it is going to work just fine. In order for your cluster to work, to build it up, you need to have two cluster interfaces and you need to have one sync interface. So I have three interfaces, two of them are cluster and one of them are sync. All right. After it has been done, you fall to cluster XL and VRRP tab over here. And over here, you just define what kind of cluster you want. Let's say I want high availability, regular cluster XL. If you want load sharing, just go for multicast or unicast. We're just going to keep it log, the status of our cluster members. As for other stuff, it's way out of this lesson, so we're just going to leave that as default value. It's going to work for you just fine if you building up a lab or trying to set up your two appliances, build up a cluster. All right, so right after you have done that, just click OK and install a policy. Right after the policy has been installed, there is one problem you might come up with. Sometimes I see that devices are, out of the box. They are not configured to be in a cluster. And what you have to do, you just go for your device, you go for SSH session and just log in there. Type in the password. And you just type in the command cpconfig. Sometimes the value that is called here like belongs to, let me see where it is. Okay, look, number 6, in my case, disable cluster membership for this gateway. So if I click disable, it will disable it from being in a cluster. It will not be able to work in that way. And sometimes that value is disabled actually. So once you type cpconfig, you're going to see enable that stuff. And I've seen customers, they are having a problem with that just because of that one specific configuration. I'm not sure what's the purpose to disable that by default, even though it's not working. If you, I don't know, just keep in mind it's here. You just need to enable that on your both devices, on all of your devices that you want to put in a cluster. All right. Once you do that, in order to activate that, just click exit 12. See, thank you. Yeah, thank you for listening, and we're gonna install a policy and see how our cluster is working. Once the policy has been installed, you're gonna see that configuration, that view in your gateways and servers tab. You're gonna see your cluster, the name I gave it, and you're gonna see a couple of devices I've added. You see? If you navigate over the cluster, you will not be able to see the CPU usage because it's all virtual, and it holds up both of your devices. All right, so in order to verify if our cluster is working, you go back to your SSH session and you type in a command which is called cpha prob space stat. So as you can see here, it's showing you all necessary information here. The cluster mode is high availability, active up, and all right. So where you typed on which device where you typed that command, you're gonna see a text local. So I've typed it in here on the second device that is on my cluster, and it's been an active one. So 100% of the load is assigned to my to that device. It's active. The second device is being standby. It's basically listening all necessary information, and once that device goes down, the second device will pick it up. When you are working with your cluster, you might come up with a problem where you don't really understand how to set up your routes on your checkpoint device, and the reason for that is basically because you create virtual IP addresses for transparent failover, and because of that, you kind of get confused where to send traffic. And I want to show you how to do it properly. First of all, if you go to your network management, network and sharing center, what do you have to do? First, if your device is connected, let's say Windows device is connected directly to your checkpoint firewall, so go for your network adapter and go for TCP IPv4 settings, and instead of a regular IP, instead of regular default gateway, select your virtual IP of the cluster. Alright, so this is the first thing. If it's not Windows that is connected directly to your checkpoint appliance, if you have the router in the middle, so on that router you have to enable default gateway, your virtual IP address of your cluster, of your checkpoint cluster. All right, so this is the first thing. So the second thing I want to point out is just go for your checkpoint device. This is the first member of the cluster, 172.16.10.1, and go for your IPv4 static routes. So what is important here to understand is, okay, I'm gonna make it really clear. Just follow me and you're not going to have any problems. So if your destination address is 172.16.10.0, which is my management subnet, my gateway will be 172.16.10.105, which is my virtual IP address of the cluster. This is where we send traffic to. This is my next hop. Alright, so for the address 192.168.1.0 subnet mask 24, which is my secured net, which is here on the right, the gateway, which is the next hop, will be 192.168.1.105, which is my virtual IP of the cluster that I kind of selected from the same subnet. Alright, and as of default route, it can be the same. This route is not even like 10.10.10.120.1 is not even on that gateway. It's the next route I have somewhere, so you don't have to worry about that. But you kind of get the idea how you have to do that. Alright, so you have to do that on both of your devices. This is one of them. Just replicate things on the second one. And another thing I want to show you. Alright, I have a couple of sessions here for you. Okay, so the first session I've typed in the command cph prop stat. Just to go a bit more into Linux, the command is watch -t cph prop stat. It just monitors this connection. Same on the second device. So I typed in the command and I can see the statuses of my cluster members. So if it's saying local, it's saying I'm on that device. On the device which is 172.16.10.1, which is taking 100% of the load, and it's being an active device. The second device is standby. So over here, I'm connected on the second device, which is being local, and it's standby. Alright? So the point here I'm trying to make, I've got another session here for you guys, and okay, let's do it this way. I'm gonna be pinging google.com. Alright, so, and I'm gonna make it unlimited ping. It's gonna ping, you know, forever. Sorry, Google, that's what I want to do. And there's a command I'm gonna type in on my local device, on my not local, the device that is being active. The command is cluster excel underscore admin down. So we manually gonna bring down the first member of the cluster that has been an active one, and if our cluster is functioning well enough, we will not see any drops. It will pick it up right away, and we're gonna see the changes of the status right here, you know, where you see the state. Alright, so let's do that. Okay, I'm gonna hit enter. Alright, so what is happening? So that device is being down now because I brought it down myself, and the second device took over. Now it's being an active one, and over here it's still going, you know, sorry Google. And I'm just gonna cancel, and we can see lost packet 0. So cluster is working amazingly fine. Alright, so just to summarize, you have commands cpha prop stat just to see the status of your devices, and you see the command which is cluster excel admin down. So if you want to bring it back up, just change down for up, and as you can see, we have that device active now. Alright, so that's it for that lesson. That's it for clusters. Alright, so since we already know how SSL VPN works, I want to go a bit deeper into how HTTPS inspection works. So basically, when we speak about SSL VPN, we speak mostly about encryption, how to encrypt data, and how Checkpoint can decrypt it and basically see all the content and check it through all its blades. But we don't necessarily need VPN for that. Maybe we are trying, maybe, you know, it's a corporate network and I want to browse YouTube, or I want to go, you know, somewhere on the internet where HTTPS protocol is being used. I don't use VPN here, but if I'm trying to access a website, and if it's in like using HTTPS type of connection, we will not be able to open it up because it's encrypted by SSL TLS, and Checkpoint is not doing VPN. It's just a regular SSL connection. So what we're gonna do, I'm gonna teach you how it works, and the reason why you need that is basically for Checkpoint to be in the middle and open up a connection, so Checkpoint can check it through all its blades, through antivirus, antibot, IPS, through all its blades. Okay, so HTTPS is a communication protocol that is used to secure access to websites and various applications via the internet. It encrypts data using SSL TLS protocol. Yeah, the problem is that if you have like a basic router that is not able to open up SSL connection, it might contain malicious activity. Even if you have antivirus, the traffic will pass through, okay? Because you're not able to open up a packet that is being encrypted with SSL. With that technology, with HTTPS inspection technology, you are welcome to do that. You can open up a connection. So, all right. These are the blades that are working with HTTPS inspection in combination. It is application control, URL filtering, content awareness. I haven't talked about that blade much, so this is basically if, let's say we don't need exe files coming on our external interface, I want to just say, okay, drop all exe files. Don't like check it, don't scan it for antivirus, don't use up our resources for IPS, just drop exe files. Depending on the policy, you can just specify a type of file you want to drop or allow. This is the content awareness. DLP, antivirus, IPS, antibot, and threat emulation. which is a part of Sandblast technology. I will discuss it in one lecture, show you maybe how to set it up. Yeah, let's do that if we speak about it here. So before we continue, we have to know that there are two ways to perform HTTPS inspection in Checkpoint environment. The first one is called outbound HTTPS inspection. It basically protects against malicious traffic from client to server. And inbound HTTPS inspection protects against traffic from internet to internal server that is located behind your gateway. This is called inbound HTTPS inspection. All right, so we have to answer a couple of questions here. The first one, is there a performance impact when we enable HTTPS inspection on the gateway? Yes, there is. So basically, if you're choosing your gateway for your environment, you got to keep in mind if it's saying throughput, let's say 50 gigabit, you can cut it in twice. You can like say 25 with HTTPS inspection enabled, because it uses up a lot of resources to decrypt and re-encrypt the SSL traffic, and depending on what kind of blades you have enabled in combination, I would say just cut it in half, the throughput of the firewall. This is how you choose the proper gateway for your environment. The second question is it possible to perform selective inspection just on specific sites, categories, or users? And the answer is yes. Definitely, you can inspect only specific sites or URL filtering categories, but it requires to have URL filtering blade license. As of now, you can buy either NGTP or NGTX types of licenses, just two types. We might actually speak about type of licenses a bit later, maybe in a different lesson, but just keep in mind you need a special license to do that. Really quickly, let's just go over the process of the traffic flow with Checkpoint in the middle, with HTTPS inspection enabled. All right, so the client sends out the HTTPS request. Checkpoint inspects the traffic. It intercepts the packet, and it checks the rule base. Does it match the rule? If no, passes without inspection. If it has a rule, let's say the answer yes, it receives a cert from the server and validates with the CA, with the certificate authority, and a new certificate is created by Checkpoint Gateway. So it kind of changes the cert, being a man in the middle. Okay, the client received the cert, and the connection is encrypted and inspected. It's easy as is. All Checkpoint has to do is to inspect a cert, check the rule base, whether we need to do inspection or no, and change the cert. That's it. And connection is encrypted and inspected. In today's lesson, we're going to learn all about how to set up your HTTPS inspection. And I've already built up a cluster here, so we're going to start by clicking the main cluster object in the Gateways and Servers tab. Just double click it, and first what you need to enable in order for your HTTPS inspection to work properly, your HTTPS inspection tab. First, you need to create a cert. Okay, just click create or import your own certificate if you don't want to create the one that Checkpoint provides. But let's say I want to create the one issued by Checkpoint. So I'm gonna do www, then I'm gonna say OMG because that's crazy, and let's say .com. This is the cert I want to use. It's gonna be my custom one. And as for the password, just use VPN123 or whatever password you want. I just like that one. The time from which it's going to be valid from to which time it's going to be valid from. All right, just click OK. It's going to generate a cert really quickly. You can view it, and then you can install it, and we will do it really shortly. Then you have to enable that stuff. Okay, once you enable that, don't click OK just yet. Go for general properties. Alright, so over here, for your HTTPS inspection to work, you have to enable URL filtering. HTTPS inspection will not work without that blade enabled. It might seem weird at first, but believe me, this is the way it is. Just enable that. You don't really need application control for that, but I'm going to enable that because as I told you in previous lessons, application control and URL filtering, they both work in pair, and I just don't want to disable that. It doesn't feel right. So, alright, I will enable that, and what I want to do, you need to go back for HTTPS inspection and then export your cert. And then just give it a name. I already have a name, OMG here. Let's say I will give it like OMG, 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 because it's like, oh my god, we're gonna inspect all the traffic, right? And then click OK. Okay, they're just kind of complaining about other blade, but it's not a big issue for now. So then you have to go for your security policy, and then navigate to shared policies and click HTTPS inspection tab. Then click right in the center, open HTTPS inspection policy in Smart Dashboard. It will open up a legacy Smart Dashboard. I'm not sure about the reason why it's there, but unfortunately it is there. It's in a different tab. You have to navigate right here to HTTPS inspection and then go for policy. And over here, once it's loaded, you're gonna see a regular policy where you specify what kind of category you want to inspect and what kind of category or website you want to bypass. Alright, so as of now, I kind of have like one rule, one specific machine I want to bypass, and I don't really remember why I have that, but over here, let's just go really quickly. You have source. As for the source, you can click any kind of machine, your local users, users integrated with your Active Directory. What you can do as well, you can set up zones and stuff. Regular firewall. As for destination, just gonna close that. As for destination, you can set up anything, specific address, same thing, right? Just go over things are available here. And the most interesting thing I would say is the site category. Over here, you can select categories of sites. Basically, this is why I told you this works with URL filtering blade. This is part of that blade. And you can select education, entertainment, alcohol and tobacco, whatever category you really want to inspect. The rule of thumb here, you want to bypass, let's say, financial services, the services you really trust, and you don't really want to overload your device. This is the rule of thumb, and inspect everything else. Everything else that is not trusted. You're going to inspect it. And my rule here pretty much is going to inspect everything else. I don't care for CPU usage, since it's a lab. But anyway, then close that tab and install a policy, and then what we're gonna do, we're gonna get the cert we downloaded, and we're gonna install it on the machine so we don't see the error in the browser, and we're gonna test how it works. Okay, let's give it a bit of time. Let's install it and see what's gonna happen. We didn't experience any problems during the policy installation, so let's just say close and navigate to our cert that we exported right on the desktop. I'm going to grab that cert, copy that, and move it to a different machine just to have a proper test. Since I've already used it on that machine so many times, it might have gotten, I don't know, confused. It's just a bit weird. So I'm going to be using on a different machine, which is called only anti-ransomware. I still have it on my topology. So okay, I've just copied that. I'm going to double click it, install the cert, and install it, let's say, current user. And place it, you know what, okay, let's do current user. No big deal, we can install it under both. Then click next. Okay, finish, and yeah, they're giving me messages. It might be bad. Okay, I've just installed the cert, and then I'm going to navigate to Google and try, let's say, website. I'm going to use in Blizzard. Then double click the website, and let's see what kind of cert we have. Yeah, I really like to play games. Let's check the cert. Alright, so as you can see, we have OMG cert installed, and yep, we might check the details as well. OMG. Now we're inspecting the traffic, right? just to sum it up really quickly, for your HTTPS inspection to work properly, you need to have other blades enabled. As an example, it's URL filtering. You can have other blades as well. Let's say IPS or antivirus. If you get a virus and it's spotted by your checkpoint device, and if you have HTTPS inspection enabled with your antivirus, you will see it in the logs without any problem. You will not be able to even to install a policy without those blades enabled. And what you want to see? You want to see the cert that's being exported here. That type of HTTPS inspection is called outbound, because you making an outbound connection to a website. If you want to, let's say if you have a server inside your behind your checkpoint device, and you need to change the cert for that for other users, you need to have inbound HTTPS inspection. It's a bit different process. It's not for that course, but at least now you know how to do that, right? Threat emulation is a part of Checkpoint Sandblast technology. What it does, it checks and blocks unknown malware. It's doing its job by having running operating systems either on the Sandblast appliance or in the cloud, and they emulate the file to verify if the file is actually doing what it is supposed to do. If the file is malicious, it's getting blocked, even if it's SSL encrypted. Threat extraction is the second component of Sandblast technology. What it does, it basically deletes all possible risks and rebuilds the file, so users don't have to wait until the file is being emulated in the threat emulation blade, and making it more secure. I will actually show you how it works. That's why I have that scenario here prepared for you, okay? So let's say a hacker wants to get some information from the client, and the way he's going to do that, he's going to send out an email with topic, you have won a lottery, and it has like resume you have to file. A client will open it, and it's going to get infected. It's going to reach the infected server, and the server is going to exploit the vulnerability, like the flash vulnerability. But it's not going to happen because we have Checkpoint on the perimeter that's protecting our network, and Sandblast as well. So here we have Checkpoint as a gateway and Sandblast somewhere in our network. Hacker sends out the information to the client, Checkpoint intercepts it and forwards the resume to the Sandblast, where it's being emulated in different operating systems. At the same time, what Checkpoint does, it converts the XLS file to PDF. We can leave it the same as XLS, but regardless, it's being converted, it's being reassembled. The client gets the file, it's the converted version of the file, whether it's PDF or XLS, it doesn't matter, it's not original. If he wants to get the original, he has to click the link in the file and click confirm. The file is being emulated in a Sandblast. If it's infected, it's getting blocked. If the file is benign, it's allowed. The client received the file, everyone's happy. This is one of the scenarios we can implement Sandblast in a customer's environment, but some of the customers might not be happy that their device is being overwhelmed with too many files. What we can do is the second way we can set it up. Actually, we have way more than 2 ways to set it up, but this is the second one. We can perform hybrid mode. All the private files will go to the Sandblast, which is located like we have here in the local network, in the protected network. So the private files will not go anywhere, and we can send all other bunch of files like exe, executable files, to the cloud, to the Checkpoint cloud. The way licensing works, if you want to set up a hybrid mode, you're gonna need NGTX license 100%. NGTX license include T-Cloud license subscription, so regular NGTP license is not gonna work. NGTX for the gateway include a certain amount of files for each device that can be inspected in a cloud, emulated in a cloud. Let's say for 5400, it's gonna emulate 25,000 files per month. For different appliance, it's gonna be a different number. If you want to use your local Sandblast appliance as MTA, ICAP server, or API, you're going to need to install the NGTX license on the Sandblast as well. So basically in that scenario here, what's going to happen? The gateway will basically check the traffic, send out files to the SandBlast appliance for the emulation. At the same time, the gateway will extract the files as a part of threat extraction blade, and some of the files that we specify in the policy we will send out to the SandBlast service to the cloud. SandBlast will be able to work as MTA and protect the Exchange server, protect all the mails that come and go, and stuff like being the ICAP server. So all the ICAP clients will be able to send out the files for analysis or through the API. You don't have to buy NGTX license for your SandBlast appliance if you're not going to use those services. But what you can do here, you can use your gateway as MTA to receive an email and send out all attachments to SandBlast for analysis. And use your gateway as well for threat extraction for web. But you're not going to have ICAP server functionality or API for SandBlast. This way you're not going to need a license. And now it's time to show you how to actually implement the hybrid mode for SandBlast. Okay, we have our gateway object, which I call threat emulation. We're going to double click it. And here I already have it enabled, but I'm going to do it one more time. So threat emulation is the blade for emulating the file, threat extraction for actually extracting and rebuilding the file. Okay, I'm going to disable this for now and then enable it again so you see what happens if you do it the first time. Okay, for now it doesn't matter. I'm going to set up the cloud emulation service where I'm going to emulate the files, since it doesn't really matter because I'm going to make it hybrid anyway. I'm going to do this like this for now. It's taking a bit of time. Okay, checking threat cloud compatibility, and it's going to be great. It's going to work just fine. All right, all right. Okay, now it's active. It's working just fine. I'm going to click finish here. Then we have to proceed to the threat emulation tab here in the general objects. And what we're going to do, activation mode according to the policy, and then we're going to set up the policy. And the analysis location, what I want to do, okay, I want to change it for this gateway locally. Okay, that's what I want to leave now. We're going to go to security policy here. We have the access control here where we have firewall and application control blades. And here we have threat prevention where we have IPS, antivirus, antibot, threat emulation, and threat extraction. We're going to double click it here or click edit. And we have threat emulation, threat extraction enabled here. Just open threat emulation tab and go for emulation environment. Here we have according to the gateway. This is going to look inside the gateway and servers object and do as we said. Emulate it where we specified. It's going to take place on the gateway locally in the SandBlast appliance. The way I change it, the way I specify the hybrid mode, I click general, and here I have all the types, all the files I can emulate, like 7 out of 66. This is by default. And I click here, process specific file types, families, and then configure. Tada! This is where we specify emulation location. This is what we have by default specified in the gateways and servers object. And I can change some of the files for the cloud. Surprisingly, you're not able to specify any other files but this, which is weird. I need like exe. Okay, don't panic. What you can do, just cancel here, then go back here, process all enabled file types. Click right here, looks like a link here, and then specify all the file types you needed for emulation. Let's say you need this, TGZ, you need this, ISO file, and I need to find my exe file. Okay, here it is. I click and click OK. Okay, changes will be applied. Then go back here. Now we have 11 files. Click and configure. Tada! This is all the files we specified. This is how we do that. Then click exe, threat cloud, and click OK. Alright, so here's what we're going to have. By default in the object, all these files gonna take place as we specified. It's gonna take place in the local gateway as we specified in the object, and this file will go to the thread cloud. Then click OK, publish the policy, push the Hey everyone, and in today's lesson we're going to discuss how to perform a transparent upgrade in a cluster. You are going to learn a couple of really interesting things here that you can apply whether you have a cluster or not. If you do have a cluster, that's going to be the most beneficial for you, that lesson. But if you don't have it, it's still useful because basically the upgrade process is the same whether you have a cluster or a regular management server or a standalone machine. It does not matter because basically if you have a Gaia operating system installed, it is absolutely the same process and you're going to learn how to do that. But in that lesson, we're going to go a bit more deeper into how to perform an upgrade and to make it transparent to the user. So basically, if we have a traffic going through our firewall, I don't want my production to be stopped when I'm performing an upgrade because I have to restart the system after, a new update is being installed. I don't really want that. And the process when you do that in a cluster is a bit complicated, but it's actually not if you learn, it from like my way from that lesson, and it's going to be really beneficial for you maybe in the future to use it as a guide, as a more advanced way how to perform an upgrade. Anyway, let's begin, guys. I'm going to show you first in a topology what we're going to be doing here. The most important thing here is to be focused on the statuses on our cluster members. I want you to be really aware of where you are performing a command, whether it's an active device or a standby. Just, keep it in mind, and it's going to be really helpful for you. I'm going to be labeling that in a topology, or when we are actually performing these commands. You will see that in the lecture. So, without further ado, let's begin. I've got a management server here to the left, which is pre-upgraded to the version R80.40. And our cluster, active and standby devices, we're going to upgrade a standby device first. Once we go through the installation process, it's going to be a down state. And then, once it's rebooted, it's going to go to the ready state. Then we're going to upgrade our first device, and it's going to change its status to down. And the second device that actually was upgraded first is going to take over. So once we upgrade them all, they're going to change the statuses to active and standby. Pretty easy procedure, right? I've got two SSH sessions here, one for active device, another for standby. I use that command to watch the statuses of my devices. And we are going to be using that for the rest of our lesson. All right, so we log into our stand device first that has that address. All right, so we're just going to log in there, type in the username and the password. All right, so next, okay, let's just open up the party session just to monitor which is the active one and standby. As you can see, 10.1 is being a standby device. Navigate to upgrade CPUs, statuses and actions. Open up all updates, not just recommended ones, but all of them. So right here, I already have a pre-installed, not pre-installed, pre-downloaded version of R80.30, and we're going to click upgrade. So it's really important, don't click install, because if you do that, you're going to clean install the system. I kind of made this mistake a long time ago. It's not horrible, but just keep in mind, just click upgrade. All right, so we are doing that on our standby machine. And I'm going to run some ping to Google just to verify we have a connection. It's not dropping in any way. All right, so we have the installation process running, and at that time, so over here on the second machine, you will see it's being standby, and once it's rebooted, it will go to down, which will not change anything in the sense of, traffic going through the firewall because we have an active device doing all the job. But that's the whole point. We are starting with a standby device just to be sure nothing bad happens at that point, right? All right, so let's just wait until the system is rebooted and we see what happens next. and device went to down state from being a standby, as I told you. But just let's give it a bit of time until it finishes starting up all the process, especially takes a bit of time after an upgrade. It does take a bit of time until system actually brings all process back up, and sometimes it just disconnects from PuTTY, from SSH session. Just give it a bit of time. It's an upgrade anyway. We might not be able to connect to our standby device, but ping is still going. I've got something going for me, right? At that point. Alright, so at that point the device has to be in a ready state, and I truly wanted you to see and wait all that time, until it's back up and it's in a ready state. Because some customers, they just rush in and say, hey, it doesn't work, it's not ready, something's wrong. And just I wanted to have that pause here and for you to listen to music in the first place. But I mean, just for you to understand, you have to wait here, you have to be patient, for your system to work. You need to know where you have to wait and where where it's a problem that you have to wait too long. At that point, it's fine that you have to wait. It's a good thing, right? Yeah, I'm gonna refresh my cpha prop stat command here just to verify my status and reconnect for the device that I've just upgraded, just to make sure all processes are up before I install a policy. Alright, so let's just log in just to verify our Gaia portal is back up online, ready for duty. Let's see. Alright, look, this boy is working pretty hard. Nice. So we're gonna go for our smart console, and you can see red cross everywhere. So what do you do here? Change the version for the latest one, for R80.30. All right, then click install policy. Just want to say that we've just upgraded one device for the latest version, and the previous device is on the version which is R80.10. That is absolutely fine. That is the whole point here, and I'm going to explain you why. All right, let's give it a bit of time. All right, so over here, just you have to deselect this thing for gateway clusters. If installation on a cluster member fails, do not install the cluster. Okay, deselect this and click OK. It will only install the policy on the freshly installed system because it matches the operating system we've selected in Smart Console, which is R80.30. You see where I'm getting at? It will only install it here on the latest, version. Okay, you can see in the policy, right? The installation succeeded on the device 10.1 succeeded, and the other device, it didn't install the policy over there. Even though we have installed a policy on that device, it's still being a ready device. An active device is an old device. So what we do, now we have to type that command on that ready machine. Just type in the command that I type here, which what it does, it synchronizes the connection table. It synchronizes the TCP and UDP connection table that is being stored in kernel. Actually, that's the whole point of the cluster. Once we break one device, a second device takes over. But in that particular instance, when we are messing with versions, with policies and stuff, we kind of manually break the cluster. So you have to manually type that command to synchronize your cluster members. The command that I've used does not synchronize dynamic routing. So if you need to synchronize dynamic routing, if you know you have that in your environment, if you know for sure you have it, you just don't use no dr in that command. Just don't use it. I always recommend just verifying a guide, the specific command. But so here I just give you an idea how to do that. All right. So the next thing we have to do is basically the most important thing here. We're gonna connect to the active device via the SSH session. So right now I'm just gonna check the status one more time, whether it's synchronized and everything. We can see the statuses are active and ready. And to make a failover, a proper one, we have to type in a command cpstop on the active device. So I have so many tabs open here, but I hope at that point it makes sense to you. We have two SSH sessions, active device, standby device, and we're gonna type in command, cpstop on the active device, and we'll fail over for, our ready device with our freshly updated policy. That command here that I type all the time kind of gives the information about the synchronizations. I can check what has been synchronized, right? I'm just being very cautious about this just to make sure everything's correct, and I do recommend for you to do the same because it gives the messages what's happening in your system. All right, let's type in cpstop on our active machine, and now we're gonna see the failover. Okay, let's see what's gonna happen. Okay, now it's the most interesting moment. Okay, look. So we have a lost connections on our active one, and it failed over. As you can see, there is a timeout for ping going on. It's gonna go back up, but we didn't lose any connections. We're still connected to the internet because my machine is connected through my checkpoint firewall. Still has internet connection. It's gonna go back up. I'm gonna explain you the reason why it's happening to ping. Okay, let's just try open up some website. Okay, let's go. Try and see what's gonna happen. All right. All right, it's back up. It's back up online. So the reason why we have lost the ICMP traffic is basically because it's neither TCP or UDP, and it's fine. I think the reason why we lost just a bit of connection is because of some layer 2 issues. It has to look for ARP of the virtual IP address of the cluster, blah, 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 whatever. But still, we still have access to the internet. It took us like 3 to 5 seconds to fail over. I'm not sure about, like, that's the whole point. When I open up a Google connection, it's a freshly new connection. It's still layer 2, you know, so to say, but it kind of synchronized all connections. I call it transparent. I guarantee you it is transparent. So now what we do, we connect to guide to a second device, and I already have pre-downloaded our 80.30 for a second device. We go for upgrade and we install a system. So once we do that, and you know the installation is completed, we go for Smart Console and install a policy on a second device. So basically we install it on both devices now because they have the same version and they can, you know, build up a cluster without any problem. All right, so let's listen to some music, wait until the system is being installed, and yep, that's pretty much the end. You know, let's just enjoy the process, the nature of that creation, whatever, guys. Let's just watch it. This is another a little bit advanced lesson, and we're going to be speaking all about IPS, about different types of IPS. We're going to check the packet flow in our UTM. We're going to learn the difference between IPS and a web application firewall, and the difference between antivirus. And the second part of this will be a lab where I explain the IPS configuration and how to optimize that in checkpoint environment. IPS is short for Intrusion Prevention System, and there are two ways how we can implement that system, implement that solution in our environment. The first way is called host-based IPS. This is basically we install a software on a remote peer that we are trying to protect. And the management server is either located on the same peer or somewhere remotely. There is a cool thing with that type of IPS. You can basically scan each machine where you have IPS solution installed, and you can see what applications are installed and form and build a policy based on these applications, specifically and granularly for each user you're trying to protect, right? The problem with this, it's way more harder to protect each user because you don't have sometimes admin rights, sometimes the computer is turned off, sometimes the signatures are not updated because the computer is turned down, and you have to update them. Without these proper signatures, IPS is worthless, right? So we have another type of solution for that purpose. We have network-based IPS. In that type of solution, you have IPS either installed on your firewall, and in checkpoint example, this is part of threat prevention blade, and will be installed on our firewall. But IPSs, right? They exist. They can be separate from your firewall, and they are usually closer to your network. So the firewall is facing the internet, and the IPS is behind your firewall. So first, the traffic will be filtered by your firewall, so your IPS don't have to worry about scanning unnecessary traffic. Okay, let's assume on our remote host we have Adobe application running in some browser, and I've just found a vulnerability, Adobe Flash Player, copy pixels to byte array, and you can verify and check the description how we can exploit that vulnerability. And if the hacker from the outside is trying to exploit that vulnerability, once he goes through the firewall and the firewall accepts that traffic for some reason, it goes to intrusion prevention system, and it checks what inside the packet, and it checks that signature and blocks the traffic from accessing the host because he tried to exploit our vulnerability. The same thing in host-based IPS. The only difference, the traffic is getting inside on your host computer, and it's being blocked by the software that is installed on your PC. Actually, this is another reason why it's better to use network-based IPS. Basically, you don't utilize your host machine resources. You have a dedicated solution for that. And because Checkpoint only has network-based IPS, we will be speaking only about that type of solution. And network-based IPS has two modes in which it's working. The first mode is called inline mode, and this is where you put your IPS, so the traffic actually goes through your IPS. If the traffic is being blocked or it's fault positive, there you go, the traffic will stuck in your IPS. It's basically between your host and between your firewall. And a second mode is called monitoring mode or promiscuous mode, and it's placed somewhere close to your firewall, but not between your host and your firewall. I would say that type of solution is called IDS, intrusion detection system. There are some cases where that is actually better, but in my practice, when you get IPS, you usually want to use it. You want to use it in prevention mode, in inline mode. Some people say if you use it in inline mode, you get too many false positives, and this is true unless you optimize and configure your IPS solution properly. And this is I will record a second video how to do it properly, so you have full control and less false positives. Alright, so now let's discuss how the traffic is flowing in our NGFW or UTM type of solution. What is happening inside the firewall? Okay, let's assume we have firewall blade enabled and we have IPS blade enabled. And the traffic, okay, so we have internet and we are trying to open an access to our server inside our network, and we are sending a SYN traffic. So first the traffic gets to the external interface and it's being checked against the firewall policy. And the firewall policy is basically allowing traffic based on source or destination or a port address, either dropping that or accepting that. If the traffic is being dropped, it never gets to IPS daemon that is running on your checkpoint appliance. If the traffic is accepted, then of course it's being added to your kernel connection table and then moves to IPS. In IPS we have three modes. We can either enable detect. That type of solution is called intrusion detection system. We can do a prevent or inactive. So we deactivate IPS for that specific source or destination. The point I'm trying to make here, the IPS is checked always after the firewall policy. It is logical. You don't want to check all signatures, all protections for everything. So first you want to pre-filter it by your firewall, so you utilize your resources more properly. And once it's being checked in IPS, it's being sent to internal interface. And now let's talk about the difference between intrusion prevention system, a web application firewall, and an antivirus. An antivirus that is also a part of threat prevention and checkpoint environment. So to begin with, IPS is a solution that is based on signatures. We update a signature, we update a whole bunch of signatures on our solution, and if the traffic contains that signature, contains that type of attack for a specific application, we either block it or we detect it. It is not aware of the specific application. It doesn't know the behavior of the application. It only checks for the signature. I'm not a big expert on web application firewalls, but the difference between IPS, that web application firewall is application and user or session aware, and it is usually always used to protect against OWASP top 10, like cross-site scripting, SQL injection attacks. Although Checkpoint have some features that are related to that, but in a really limited way. So just a quick example how the, let's say, machine learning can be used in web application firewall and can actually protect from can protect your application without having a signature. Let's say you are sending a basic GET request to your server and you want to get an item, and the item name is lemon. So the pattern and the algorithm between each letter is green, and the system knows that exactly that pattern is fine. It is not an attack. But let's say we're trying to place an SQL injection attack. So we have apostrophe, we have O, and the system knows that apostrophe and O is not something that we expect to get on that web application. So it kind of creates an anomaly. When I said it's application aware, this is what I'm saying. So that pattern does not match what we usually see in that application. So that is the difference between IPS and web application firewall. You're not able to protect from thousands of attacks that exist on the network that are based on signatures with your web application firewall, because it's not designed to do so. And the same way, you're not able to do that protection, that complex protection with IPS that a web application can provide. And really briefly about antivirus. Antivirus is also signature based as IPS, but the difference is using absolutely different signatures than IPS, and it checks the files that are inside the session, inside our packet, whereas IPS is checking the vulnerabilities inside the applications. So that is a big difference. Sometimes when you work with threat prevention, you might see that some traffic is being blocked by antivirus, and sometimes the same traffic is blocked with IPS. Sometimes this is the case when the attack is a bit more complex and is trying to exploit a vulnerability and has a file that is trying to put in that vulnerability, if you know what I mean. So sometimes, usually IPS is getting the traffic first, so it doesn't even get to antivirus, but sometimes antivirus might actually see the hash sum, the signature for that specific attack, for that file that contains a malicious type of thing. And as I've mentioned, Checkpoint also contains stuff that can help you with, let's say, a WASP top 10, like SQL injection attack, cross-site scripting, and so on. But it's very limited, and you can enable that and try to play around with this. And in the next lesson, I'm going to show you where you can do that. But anyway, really briefly, if you go to security policy and then move to IPS protections, then you're going to see a type of protection. So the first one is called threat prevention or something, and it has all signatures. In my particular instance, it's 10,000, and you have core protections that are built into the daemon of IPS. I have 39 of them, and one of them is called SQL injection with a CV. It contains actually CVE. So anyway, once you click it, you are able to modify it, and if you understand how SQL injection attack works, you can see that these patterns, they are here, and you can click a plus sign and add a pattern you want, or you can delete a pattern that actually exists here. Hello everyone, and today's topic is IPS part number 2, and the exact name of the topic is called IPS optimization. Right now we have only one part of that topic where I explain how IPS works in general, what is the difference between IPS and other similar solutions, but I've been postponing releasing that lecture. I'm not sure why, but anyway, it's been planned, and now it is the time to show you the process of IPS optimization. At first, you might think that the procedure is really easy. All you have to do, you just go for your general object and you enable IPS, go to your policy, activate all protections, and you're good to go. That's what you might think, and in some way, you're right. This is how it works, but there are so many details to it that if you don't consider them, you might actually reduce the production of your firewall, and you do not use your IPS in the way it is supposed to work. Anyway, so the first step to start working with IPS is to basically enable it in your general object property in the main tab, general properties. You go there and you activate IPS. That's what you do. Then they ask you how you want to treat your IPS. The first option is according to the threat prevention policy, which means then we go to security policy, to threat prevention tab, and that's where we're gonna fully configure our intrusion prevention system. Or it's gonna be detect, just to the traffic is being detected, but not being prevented if the threat was found. Anyway, honestly, I've never used that one, and I'm not sure about the purpose of this. Was the purpose just to detect when you have a full capability to prevent? Okay, we're gonna activate prevent according to the policy, and then click OK. Once it's done, you have a tab right here which is called IPS, where you have a little bit more granular control over this blade. Anyway, so they ask us again what is activation mode, and we're gonna double check. We're gonna say according to the threat prevention policy. That's what we're gonna do. We're gonna leave it by default. We are not gonna bypass IPS inspection. when the gateway is under heavy load. Basically what it means the IPS blade will not work when you have a full CPU utilization, when it's under 100%, or when your RAM is 100%. Honestly, it's not worth it. I guess you can understand the reason why. If the threat, basically maybe someone is attacking you or giving you too much traffic into your system, and the way IPS works, it has to check all the signatures on these specific applications on where the attack is being performed. And honestly, if you enable this, if you check it, it feels like they can honestly destroy a system without your IPS actually working, so they can destroy your resources. You know, your gateway runs out of CPU power before actually the threat is being checked. So anyway, we're gonna leave it. I'm not even gonna click on advanced. No need here. Another really important topic here is how your IPS is being updated, and now we're gonna talk all about that. Anyway, once the IPS has been activated in general properties, go click OK. Then we're gonna move to security policy. Let the Smart Console accept the fact that we are enabling IPS. Anyway, before we proceed to the policy, we have to go to Manage Policies and verify that our Threat Prevention Blade is enabled. The way you do that, you click just the way I did. You go for Standard Policy, you click Manage Policies and Layers, and go for Policies. Over here, you have your one standard package, which should be here by default. If you have something else, and you know that policy you're working with, you should click there. Anyway, so you click here and go for Edit. You have to make sure that the threat prevention check sign is on here. You can double check if you click there, and you have this tab. And over here we have threat prevention. We can add new layers, and you know what? We might do that actually in this lesson. But anyway, so right now you should have that type of thing. So we make sure that the threat prevention policy is here, so at least we have something to work with, right? Anyway, so here's our access control, and here's our threat prevention. We go to our threat prevention, and over here we have all blades that are related to threat prevention, which are signature based, file emulation based, and so on. Right now I have threat emulation, I have threat extraction enabled, but anyway, let's go and enable IPS. What do? You click on that profile and go for Edit. When you click Edit, you go for IPS. And once you do that, you have a tab here, which appears right after you enable it. And right here, you have the thing called Updates. By default, in some versions, it is checked, and in other versions it's not checked. The most I see the most when that configuration is checked, and what it means, your newly downloaded signatures will be put in a staging mode. And honestly, I believe this is the proper reaction of the firewall, to place it in the staging mode. And what it means, what is a staging mode? Staging mode is applied to newly downloaded signatures, new protections for IPS with your regular scheduled updates, and they're, instead of being prevented, they are detected. You might feel like, hey, I've updated my IPS and the threat is being detected. What's the point? It's still, the user receives it and the hacker is able to utilize whatever the malware he was using. And that's the truth. But the problem here, if you set prevent to all newly downloaded signatures, you don't know how it's going to work. You are not sure that the device, that your IPS device in that particular instance checkpoint is not going to be fault positive all the time. maybe if you set it to prevent and there is a newly downloaded signature, you might actually stop the production because it's fault positive. You're not sure because that protection has not been tested. That's why it's in detect. And as a security administrator, a checkpoint security administrator, your job is to then monitor the all newly downloaded protections in logs and monitor and see which protections are being used the most, if they're fault positive, and so on. And we're going to talk about this as well in that lesson. It is your job to then move these specific protections from detect to prevent. Especially if you're just starting working with IPS, there is no wrong answer how you set it up. One part of working with IPS, you have to tune it over time. It does take over a day, over a week, over a month to fully tune it, and when newly downloaded protections actually being released, you have to work with them as well. So it's an ongoing process which takes your career. Let's go this way. Anyway, so how to download these protections, how to update them. First, you have to click on the tab which is threat prevention, and you go for policy, and then you're gonna see the thing called updates. These are the updates that are related to threat prevention policy. Once we click here, takes a little bit of time for my smart console to load it. For some weird reason it takes a while. Anyway, publish session to release. Okay, it's locked by my management server. Let's publish the session to... Yeah, basically we are not able to perform an update because all of the changes I'm making here, they are in Smart Console, and the changes are not being published to the management server, so the database of the management server doesn't know about the changes that I'm making. Once I publish, I'm publishing all of these objects, all of my changes to the management server, and we are able to proceed with the update. Once you enable IPS, if it's your first time, you always have to go for update now. Depending on the version that you are running, which is let's say R80.30, R80.40, or it doesn't matter, you have a specific date. Let's say maybe it's to 2007, which is like a database when that version was released or something like this. But anyway, you have to update it because the signatures out of the box are pretty old. Anyway, there are different ways how you can do that. You can do it as using Smart Console. If you click it right here, it's going to download it via Smart Console and then load it to management server. You can click download using management server. It will download it right to your management server. Remember, Checkpoint has a three-tier architecture, which is Smart Console, which is a management server, and your gateway. Or you can perform an offline update, but it's a different topic. If you don't have internet access or somehow you don't want to utilize your internet traffic, you can perform an offline update. There's a whole SK on support side how to perform that action. But anyway, so you go for update now, and let's say using Smart Console. This is my favorite way. This is how I've been doing that for years. The second way, because like honestly, the reason why I don't like to use the management server as an update platform is because I make all of my changes here in my Smart Console, and it feels more natural for me if I'm making the changes to IPS through the Smart Console as well. I do recommend that you set up a schedule for your updates. The normal schedule, don't do that like every day. There is no need for that. I do recommend at least once a week, and especially when your device is not under heavy load, not in busy hours. Maybe Sunday night is fine, or maybe Friday evening. You have to choose for yourself. Anyway, once a week is more than enough, and over here when you click configure, you can see when it will be updated, at what time. You decided for yourself when is the best time for you. Anyway, so we've spoken about the staging mode. That topic is really important because it does affect how your newly downloaded protection is gonna work. And honestly, IPS is all about newly downloaded protections because most of the hackers, they try to use new exploits to for vulnerable systems, and rather than something old. But it differs. Anyway, you shouldn't disable it for all signatures as well. Anyway, so when you go for FW log, where you monitor all of your stuff that's going on with different blades, you go for queries right here. And right here, you're gonna have the IPS. You're gonna have threat prevention, and let's find where's our IPS. IPS is right here, and as you can see, we can filter it by different types of protections. We have all, not prevented, staging, and follow-up. As I've mentioned before, staging is the newly downloaded protection, and we don't really want to put it under prevent because it might affect and disturb our production. Anyway, just because it is logs, you will not see anything here unless your firewall triggers that specific protection. The next thing we do, we download new protections and we apply them and install the policy. But right here, so the point here I'm trying to make, to monitor all of these newly downloaded protections that are set to detect, you monitor them right here in the queries and go for IPS blade and go for staging. If you wish to work and then put them into the prevent mode instead of detect, what you do, you go for a security policy and then move to threat prevention policy and then go for IPS protections. And once it has been updated, you will see in the activation filter right here, you will see the staging mode. If you select the profile, the one that you're working with in threat prevention policy, I've actually selected all of them right now, so we can see. You will see a staging mode. If you have any protections in staging mode, you can monitor them here and then switch them to the necessary mode. You can disable them, you can move them to prevent for your specific profile. Okay, we have just talked about the newly downloaded signatures and how to treat them. The next thing is to basically how to properly work with a profile. Because as you can see, the newly created profile by me, which is Sandblast profile, so I'm not going too fast, I just want to show you this profile. Okay, it's right here. It is a profile that I have created to work with Sandblast, and I've enabled IPS here as well. A problem with Checkpoint basic profiles is their limitation, is we don't really know which protections are enabled and which are disabled, which protections are in prevent mode and which are in detect mode. And you can verify that information if you go to the same tab, IPS protection, where we have already enabled all of them. In a view, as you can see, show selected profiles 4 out of 4, and you can see them right here. Profile number 1, let me just somehow demonstrate for you. Okay, the first one is Sandblast profile. This is the one I have created manually. There is a strict profile which is more CPU heavy. It takes way more resources because it enables more protections. There is a basic profile which is which disables lots of protections to save some CPU resources, and there is optimized. It's kind of a mixture between strict and basic. I'm not sure honestly how to characterize this. Some of the stuff is enabled, some of the stuff is disabled, and if we scroll down, there is just like lots of protections, like a lot of them. I would say thousands. Okay, let's just scroll down like this. Let's just see a little bit more information. The point I'm trying to make here is how random it is. You don't really know which is going to be enabled, which protection will be disabled. Let's say the optimized profile. That protection right here is disabled, but that one is enabled, is in prevent mode, and it's completely at random. And that's a problem. There are two ways how you can work with this. The first way, you manually go and enable these protections and see if that actually kills your CPU or not, but you don't really want to do that in production. and it takes a lot of time and resources to do so. How you can work with this, I'm gonna show you a trick. I'm gonna show you a trick that's gonna help you, and this is a proper way to work with IPS profile. Okay, first of all, being a security engineer, I don't really want to waste my time enabling and disabling thousands of protections, and you know, even if I do, I'm not sure if they are taking a lot of CPU resources or not. It's random. It's not really. It's not good. To work with this, what do you have to do? You go for security policy and go for manage policies. What we're gonna do, we're gonna create a completely different profile for IPS under the threat prevention blade. We're gonna work with our standard policy. We're gonna go here and click manage policies and layers. Right here, remember I already talked about this, and now we're coming back here. We're gonna edit this policy. We're clicking right here, and in threat prevention we're gonna click plus and add a new layer, which will be completely dedicated to our IPS. We're gonna call it IPS. There is nothing here. We're not able to choose anything as we would do in our access control, but that's fine. It's fine. All we have to do is just separate our IPS. Okay, so now we have threat prevention, a general policy, and now we have IPS. We're gonna click OK. Wait just a little bit of time until checkpoint allows us to continue. Or Windows, or my laptop. Okay, so now we're closing that and moving to threat prevention policy, and now we have two tabs here. The first one, threat prevention, as we would have before. Now I want, since I already have IPS, which I will be using fully for IPS, in my threat prevention policy, which I am actually using for Sandblast, I want to do edit and then disable IPS here. I don't want to use it here, and because I want to fully focus on Sandblast and other stuff over here, and then click OK. It's gonna make a lot more sense once I finish this. Believe me, I've got a point to say. I've got something to say to the world. We have disabled IPS right here in threat prevention, and then we're gonna move to our newly created IPS. Okay, the first thing I want to do, I want to fully dedicate that rule to my clients that are defined behind my checkpoint, and we're gonna create another rule which will be fully IPS for our server, because as you can agree, these protections differ from each other. The client protections and server protections. Okay, and let's call it server IPS. Protected scope can be any site, any, you decide it for yourself, whatever subnet you want to protect. Anyway, so let's start with client. It's gonna make way more sense for you now. So we're gonna click edit, and now we're gonna change our profile from optimized. We're gonna call it client IPS. We're gonna disable everything except for IPS, since it's our IPS related topic. And as for the active protection and for activation mode, what we're gonna do, we're gonna enable everything, so our IPS profile will catch everything. So we don't have any detags, we don't have anything for inactive and stuff like that. We want everything enabled. So in activation mode, everything should be prevent to make sure the threat is caught by checkpoint. In severity, what we do, we go for low or above. If the severity of the threat is actually low, we're still gonna catch it. The performance impact is high or lower, even if the it's CPU intensive and can destroy our device. I still want to enable that because I want to make sure that threat is caught by my checkpoint. But the way to optimize that, the way to help our device not to crash by under heavy load, is actually really simple. We go for IPS and for our additional activation right here. And we want to activate IPS protections according to the following additional properties. Since it's our client-based IPS rule, we need to know our infrastructure, right, before we work with IPS. Let's say that in my particular environment I don't have any Linux machines. Then I'm gonna only use Windows. Only Windows related products, related protections will be activated. And just to make sure, I want to deactivate protection. I want to deactivate Linux. As a product, as a vendor, I don't have these protections and I want to deactivate it. So when that specific threat is coming through my perimeter firewall where we have IPS enabled, it will not activate these protections. That's why it will not use the CPU and RAM. Another thing we can do here, we can type in client, which is client related products. We go for client. And over here, the product to deactivate. Yeah, it's just a little bit laggy here for me. Let's just wait until. And over here, we go for server. There's a lot of stuff to choose from. What I do recommend, if you know for sure that some of the stuff is not used in your company, you just scroll from here, disable that, and it will be applied to all of the protections. It will take less time for you to work with that. And then you click OK. I'm just gonna call it client IPS. And then once it's created, what do you have to do? You have to right click to your optimized profile and switch from optimize to your newly created profile. In my case, it is client IPS. And we're going to do the same thing for our server. As I'm sure you would agree that the server stuff that is running on the server is completely different from what we are usually seeing in our client-side environment. So we're going to do the same thing for our server, and it's going to enable all of those protections I've shown you, depending on that additional parameters that we have set up here. By doing that, we have everything in prevent, but only stuff relevant to our infrastructure. It's just taking a little bit of time. We can wait, and I can show you that stuff in our server. Actually, let's do that. Let's wait. And we're changing that from optimize to our newly created profile, which is our, yeah, it's just a little bit laggy, client IPS. And then we for the server, we do the same thing we did for client IPS, except it will be for server IPS. Let's go and edit that stuff. Okay, let's change that to server IPS and deselect everything except for IPS. Everything should be in prevent. Over here is higher and lower, and in severity is lower or above. So everything will be activated, and now we change additional activation and protection to activate. Since it's a server, I want to activate anything that Checkpoint considers to be a server. Let's go and choose server, and let's say my server is Linux. My clients are Windows, but my servers are Linux, and I want to enable all of the protections based on Linux properties. And I don't have any service, Windows service. I want to deselect them. Windows. Yeah, I want to deselect. No service on Windows for me. So and what I want to do, yeah, and over here I want to choose client. Since it's not related to my clients in any way, let's just disable that. And over here I've already placed server. I hope it makes sense to you. We're gonna click OK. Same thing. Takes just a little bit of time, and then we move from optimize, right click, and choose server IPS. I hope it makes sense to you what we did here. This is in my opinion, the best way to work with IPS. There are a lot of tweaks and things that you can do with each protection, and that product is easy to work with, but it takes time to tune. The steps I've shown you, it's gonna simplify your life without actually compromising the security. I hope it was informative for you guys.